All right, looking at number 71, we're looking at transformations of quadratic functions. Okay, so we have our parent function y equals x squared. This is in ax squared plus bx plus c form, standard form. In this case, a is 1. Okay, we know that c is 0 in this case. So I can look at number 71, and we know that we have a negative here, and we have a plus 1 here. So this is going to be a reflection over the x-axis. Right, so in other words, the graph is going to open downward now. It's going to be a upside down U shape, or an N more or less, and this is going to move it up 1 unit. So this is my new C value, which is my y-intercept. So it's going to move it up 1 unit. Number 72, we have an A value that is 1/2. So A is less than 1. That's going to be a vertical compression by 1/2. So A is less than 1, it's a vertical compression. If A was greater than 1, it'd be a vertical stretch. And here we have A is greater than 1, so we know that it's a vertical stretch by 2. And we went down 3 units. The C value is -3, so we went down 3 units. 74 through 76, we're going to simplify radicals. So we're looking for factors that multiply to give me 96. All right, so if I take a 96 and I divide by 6, factors would be 6 and 16. Yep, 6 and 16. All right, now we're reducing to its prime factors. So 6 breaks down into 2 and 3. 16 breaks down into 4 and 4. Now, this is a square root, so we need a pair to bring it outside the radical. So I see a 2, a 3, a 4, and a 4. I have a pair of 4s. That's going to come outside the radical. It's going to become one number outside the radical. So we have 4 outside the radical. Those two 4s came outside and became 1 4. Underneath the radical, my remainders are 2 and 3, which 2 times 3 is 6. So the answer is 4 squared to 6. All right, looking at number 75. Now we're going to throw a variable in there. So let's look for factors of 252. 252 breaks down into 2 and 126. And again, 126 is not prime, so let's break 126 down into 2 and 63. Okay, so we know we have a pair of 2's at least. Let's keep going because 63 is not prime. We can break down 63 into 9 and 7. And we can break down 9 into 3 and 3. So I have a pair of 3's, a pair of 2's. So the 2 came outside, the 3's came outside. So outside we have a 2. The pair becomes one number. We have a 3. Okay, we still have a remainder of 7. All right, now let's look at my variables, right? I have x to the third. So I have x times itself 3 times. So you have a pair with 1 left over. So that pair is going to come outside and become one number. And we still have this remainder here. So outside we have 2 times 3 times x, which would be 2 times 3 is 6x. Inside my radical, I've got 7x. All right, looking at number 76, we're going to break down 32, 8 and 4. A breaks down into 4 and 2. So I have a pair of 4's that's going to come outside. The 2 is going to stay underneath the radical, so we have 4 outside, square root of 2 for a remainder. Now let's look for z to the 6, right? So if I had 6 socks, you've got 3 pairs of socks. So we've got 6 z's. We've got 3 pairs of z's. Pair, pair, pair. So 3 pairs come outside. We have z to the 3rd power with none left over. All right, let's look at some exponential functions. Remember, exponential functions are y equals a times b raised to the x. B is going to be my base. That's going to tell me whether it's a growth or a decay. Growth when b is greater than 1. Decay when b is less than 1. So in this case, I have a base of 3. My a value is 1/2. I have a base of 3, so we know it's going to be a growth function. All right, so let's look for some values of x and plot some points. So if I plug in 0 here, I've got 3 raised to the 0, which is 1. 1/2 times 1 is 1/2. So I have a point at 0, 1/2, which this a right here is the initial value, which basically is your y-intercept. So we have a y-intercept at 0, 1/2. If I plug in 1, I have 3 raised to the first, which is 3, times 1/2, which is 3 halves, or 1.5. So 1, 1.5. If I plug in 2, I've got 9 halves, which is 4.5. So your graph looks like this, right? Let's remember exponential functions have an asymptote, which in this case would be at y equals 0. All right, now we can see that we have a reflection here. So let's look at what that does to the graph. So we have negative 2 times 2 raised to the x. So again, this is your a value, this is your b value, so we know it's a growth function. So let's find some values of x and y. If I plug in 0, I've got 1 here, so negative 2 times 1 is a negative 2. So again, your a value is the initial value is the a. If I plug in 1, I've got 2 times 1, which is 2. 2 raised to the first, which is 2. So negative 2 times 2 is a negative 4. So at 1, we're at negative 4. If I plug in a negative 1, I've got 2 raised to the negative 1, which is 1/2, times negative 2 over 1, which is going to be negative 2 over positive 2, which is a negative 1. So at negative 1, I have a negative 1. So your graph is going to be like this. So it's a growth function, but instead of it going like this, that reflection, that negative sign, flipped it upside down over the x-axis. All right, now this is a decay function. We have my a value is 1, so y equals a times 1/4 raised to the x. In this case, a is 1. All right, now I'm going to do this on the back because my formatting is off. So y equals 1/4 x. I could write this as 1 times 1/4 to the x. So my a is going to be 1, so I have a point at 0, 1. Right, so let's plug in 1 right here. I have 1 times 1/4 times 1. So 1/4 times 1 is 1/4, so 1 1/4. If I plug in negative 1, I've got, let me write this differently. I've got 1/4 to the negative 1, which again, a negative exponent, what we're going to do is we're going to flip the fraction, so it's going to become 4. So we have negative 1, 4. So your graph would look like this. And again, I have an asymptote at y equals 0. It's a decay function, it's decreasing. It's a decay function, it's decreasing. All right, looking at number 80, what I want to do is I want to write the exponential growth or decay rule. Okay, so now, for an exponential function, we are going to divide y values. Right, so if I take this 0 and go to this negative concurrent point of negative 1, I'm going to take my y values and divide. So 9 divided by 3, I know I'm multiplying by 3. Same thing here, I'm multiplying by 3 to get to the next point. I'm multiplying by 3 to get to the next point. Alright, so I know that this is the base, right? The base is going to be your rate of change, which in this case is 3. So we have y equals a times b raised to the x. Well, we just figured out that 3 is b. So we have y equals a times 3 raised to the x. Now again, let's remember, a is the initial value, which is your y-intercept. So in this case, my y-intercept has a value of 9. So we know that a is 9. So the exponential function is this right there. Alright, same thing here. What I'm going to do is I am going to take my values and divide by the previous. So 5 divided by 10 is 1/2. So we're multiplying by 1/2. Same thing here, multiplied by 1/2. Multiplied by 1/2. Multiplied by 1/2, right? So the base is 1/2. The a initial value is 5. So we have y equals 5 times 1/2 raised to the x. So the decay function, because my y values are getting smaller. Alright, looking at number 82. Okay, a sculpture is increasing in value at a rate of 8% per year. Increasing is a key word. 8% per year, and its value in 2000 was 1200. What's the sculpture's value in 2006? So exponential growth, because it's increasing, is going to be y equals a 1 plus the rate raised to the time. Right, here's my initial value, 1 plus, because it's an increasing function, so plus here, the rate times the time. So this is going to be rate. Time is going to be the difference between 2000 and 2006, so 6 years. So t equals 6 years. Rate is going to be 8%, so that would be in decimal form 0.08. A is going to be my initial value of 1200. So we have y equals 1200, 1 plus 0.08 raised to the 6th. Okay, well now all you're going to do is plug it in the calculator. So we're going to open up our calculator. We've got 1 plus 0.08, so 1.08. We're going to raise that to the 6th power. We're going to multiply that by 1200. So my answer is 1904.25 cents. $1,904.25. A new car is worth $25,000 and its value decreases by 15% each year. Find the value of the car after 6 years. So it decreases. Okay, so now that's an exponential decay function. So we have a 1 minus the rate raised to the time. So in this case, again, a is going to be your initial value of 25,000. We have t as 6 years. And we know my rate is 15%, so the rate in decimal form is 0.15. So y equals 25,000. 1 minus the rate, 1 minus 0.15 raised to the 6th. So I'm going to plug that in my calculator, right? I've got y equals 25,000, 0.85 raised to the 6th. So I'll plug that in the calculator. 0.85 raised to the 6th times 25 grand. So after 6 years, my car is going to be worth $9,428.74. Number 84 says, suppose you invest $3,200 in an account paying 2.5% interest. Find the account balance after 10 years with its interest compounded monthly, assuming that you do not make any deposits or withdrawals. So we're gaining money. Okay, we're gaining money. So what this is y equals a 1 plus the rate over the time raised to the rate times the time. Okay, now, in this case, it was each year, right? So we don't have to go by periods because it's only one time a year. But if I look here, I'm going compounded monthly. So the t in this case is going to be 12. Okay? So we got y equals a 3,200. An account paying 2.5% interest, so my rate is going to be 0.25. Find the account balance after 10 years, so this is going to be t, with its interest compounded monthly, so my period is going to be 12 times a year. So again, the period, or the n, I guess I should say, the number of times per year would be 12. Alright, so we have this. So let's plug it in. We have a equals 3,200. 1 plus the rate of 0.25 divided by 12, and then raised to the n, number of times per year, 12, times the number of years, 10. Okay, so here we go. We got y equals 3,200, 1 plus, and then we got 0.25 divided by 12, which is 0.020833, and that's raised to the 120. Alright, so we're going to add 1 to that. So we have y equals 3,200. In my parentheses, I've got 1.020833 raised to the 120. Alright, so we're going to plug that into our calculator. So let's open up our calculator. We've got 1.020833. That's raised to the 120. And now we're going to multiply that by our initial value of 3,200. So we get the 37 37,993. Get out of the way, 0.9. So after 10 years, you'd be looking at that in your account, right? Alright, let's go back because I screwed up. The rate is not going to be 0.25, the rate's going to be 0.025. So this in decimal form is 0.025, my fault. So let's go back and let's fix this. This is going to be 0.025. Sorry guys. My bad. Alright, so again, this 0.25 interest rate is going to be 0.025 in decimal form. Alright, so I'm going to do this 0.025 divided by 12. So let's open up our calculator. 0.025 divided by 12. That's going to be my rate per year. And I'm going to add 1 to that. That's going to be what's inside my parentheses. Alright, so now I've got 1.00208. Alright, we're going to raise that to 120, so we're going to do the exact same thing that we just did here. 1.00208 raised to the 120 times 3,200. So here we go. Let's put in the calculator. We've got 1.00208 raised to the 120, and that's times 3,200. There we go. That makes more sense. 4,106.17. Alright, number 85. Suppose you invest $8,000 in an account and paying 3.25% interest. Find the account balance after 4 years with the interest compounded daily, assuming that you do not make any deposits or withdrawals. So here's A. A is going to be 8,000. In an account paying 3.25% interest, so my rate is going to be 3.25%, so 0.0325. T, the time, we're after 4 years. But now it's not every year, it's every day, right? So N, the number of times per year, is now going to be 365. So we've got Y equals 8,000. We're still gaining money, so it's still an exponential growth. So it's going to be a plus sign. It's going to be raised to the 4 times 365. So the number of years times the number of times per year. So 4 number of years times the number of times per year. Alright, now again, we're going to plug this in our calculator. So we've got 0.0325 divided by 365. And we're going to add 1 to that because it's a growth function. So inside my parentheses, I've got 1.00009. I'm going to raise that to the 1456. So here is your equation. So we've got 1.00009 raised to the 1456, and then times my initial 8,000. So we get 9,120.05. So $9,120.05 after 4 years.